Hi, class. Here's one of the problems about sampling distributions. I'm going to do this one, the automatic loader, coal, so you can kind of see the importance or what this is good for. So, anyways, this problem says coal is carried from a mine in West Virginia to a power plant in New York in hopper cars on a long train. Okay, so we've all seen trains with coal cars. The automatic hopper car's loader is set to put 75 tons of coal into each car. Now, of course, the actual weights of the coal loaded into each car, they're normally distributed with a mean of 75 tons and a standard deviation of 0.8 tons. So these cars vary. I mean, if you took any individual car, you might have 74.5 tons or 76 tons, because this is, it's not an exact science to get exactly 75 tons. So, the thing scoops up coal, train comes underneath, and then it pours it in there, and it's set to deliver that much. So anyways, it's got the normal distribution, so that would be the bell-shaped curve with this. Now it says, what is the probability that one car chosen at random will have less than 74.5 tons. So I'm going to do this on the calculator, show you how easy this is to do. Okay, so I'm going to go here to second, distributions, and I'm going to choose the normal CDF. Now, since this is a normal distribution curve, it basically goes from negative infinity all the way up to positive infinity. But we're interested in the part from negative infinity to 74.5 tons. Okay, we're the left side of the curve. So to put negative infinity here, I'm going to go negative second. See this double E? It's E99. So that just means the exponent is negative 99 exponent to the left, right? And then, so that's my low value. That means all the way to the left, negative infinity, if it was way over here. Okay, and then comma, and then 74.5 tons, comma, and then, so that's the low value, the high value, and then we want the mean, which was 75 tons, and the standard deviation, which was, hold on, let me take a look here. Where was that? Standard, 0.8 tons, okay. So standard deviation is 0.8, comma, and we have a probability, so this is of one car. So we have 26%, or basically 27% chance. So 1 out of 4 cars is actually going to have less than 74.5, even though they all average around 75. Okay, so about 1 out of 4, 25%, or in this case, close to 27%. Right? But the next question says, what is the probability that you could choose 20 cars? So let's say you have 500 cars lined up. And you're going to randomly, we'll use systematic sampling or something. Every 30th car we're going to grab and choose those. Okay. What is the probability that you could take 20 cars chosen at random that will have a mean load weight of less than 74.5 tons? Well, if the mean really is 75 tons, this should be a very, very low probability that this could happen, right? How could we get less than 7? If the mean is really 75 tons on this machine that it's loading, how could we choose 20 random cars and get less than 74.5 tons? So let's see what happens. I mean, intuitively, we think, well, that should be a low probability because, so we go, same thing, normal CDF. I'm going to do the same thing from negative E99, comma, 74.5, comma, mean of 75. But this time, the standard deviation is going to be our original standard deviation of 0.8 divided by the square root of the sample size. So it's 0.8 divided by square root of 20. I think that does it. Yeah, now look at that. I would only have, 0.002. So 0.2%, right? Very small, less than 1%, chance of that happening. In other words, if that did happen, if I was like the inspector, the quality control inspector, and I'm sampling cars, and I've got 20 cars, and I take the average, and it's less than 74.5 tons, guess what I got to do? I got to adjust this machine because it's not. There is no way that it is loading 75 tons into each of these cars, an average of 75 tons in these cars. Heck, I've just sampled 20 of them, and I got less than 74.5 tons average. There's my sample, X bar. And so what that's telling me is something's out of adjustment. This can't happen. I mean, it could happen, but it's got such a small chance of happening, this 0.0025, right? It's got such a small chance of happening. You have to ask yourself, and this is the whole point of sampling distributions. Either you're witnessing something very rare, and it'll be what we're going through with hypothesis tests in semester 2. This is the crux of the matter with statistical analysis. Either you're witnessing something really rare has happened, or that your machine's out of adjustment, or whatever it is you're analyzing here, right? I mean, this has such a small chance of happening that we would say, well, that probably the more likely thing is that this thing really isn't loading 75 tons, okay? Because it would just be pure luck that we chose the 20 cars out of these 500 that happen to have, less than 74.5 tons in it, and that's why we were able to average less than that. Okay, so hopefully you kind of get the idea with how powerful that can be when you're looking at populations, being able to say something about them with great certainty. Okay, hope that, hope you like that or whatever. We'll put this probably on the announcements and also in the second semester announcements, because I'm going to do a little review of the first semester recording, 2 or 3 recordings that you guys can start out by looking at when you come back next year, and that'll, kind of get you started back into thinking about statistical analysis. Okay, so there you go. That's Mr. Lonnie, and otherwise, I know it's close to holidays here, so hopefully you guys have a great break. Come back inspired to learn about hypothesis testing, confidence intervals, and the chi-square distribution. And then we'll do a really good review for your AP tests. And then hopefully you guys do really good when you get back. Okay, bye.